All right, hello everybody. Today we're going to go through 4.1.1. This is the Copier Paper Jam circuit. I'm going to make it in TinkerCAD here. I've got the schematic kind of up here on the left, this block diagram, and a couple things to point out. We've got our motor here. We're going to use the hobby motor for that. We've got our H bridge, and we're going to use the L293D for that. We've got external voltage. That'll be a power supply. And then we've got what would be in the PLD here, but we don't have a PLD in TinkerCAD, so we're just going to build that circuit with regular logic. So we're going to go ahead and get started in building everything except for the PLD in this first video. So I'm actually going to try and keep it as close to this block diagram as possible. So starting at the top left, I'm going to work my way down. I'm going to find the hobby motor here, hobby gear motor. I'm going to use that. Okay, we'll put that up in the corner. We need some limit switches, so I'm going to throw down a big old breadboard here. So I got a breadboard there. My switches that they've got for me here are these micro switches. These ones here, these push buttons. Those would be a good choice. So I'm going to go ahead and set up 1 and 2, and I'm actually going to go ahead and put the slide switch in the middle. And the reason I'm going to do that is because one of the things I need to do to test this is to press more than one switch at a time. And it's going to be pretty difficult to do with these push buttons, right? So I'm going to use a slide switch in the middle so that I can like turn that on and press a button so I can make sure this thing works. You know what? In fact, I'm going to go ahead and do them all with slide switches. That's probably the right choice. So I'll go ahead and do these all with slide switches. So that's these limit switches up here. Okay, so now we need to do our voltage divider down here. So we need some resistors. So we're going to go ahead and do a resistor here. I'll try and mimic the image as best I can. So we'll do that. That's a 180 ohm resistor. Make sure you change this to ohm. And then I got a 330 that would go from there to ground. Make that wire black. Hey. Make that wire black. There we go. And this is a 330 ohm. There we go. Cool. And then I need some power for that. So we're going to bring in a power supply. And that's down here. So we're going to bring on our power supply. We're going to end up having 2 power supplies. I'm just going to go ahead and bring them both out now. So this is going to be our regular 5-volt supply. And so we're going to set it's already set at 5 volts. That's good. I'm going to go ahead and name it VCC. There we go. Okay. And I'm going to name this one external. Easy for me to say. External. And I'm going to set that. They tell us 6 in there, which is fine. So I'll set that right at 6 volts. Okay. Oh, go away, code. All right. So I've somehow rotated my power supply. Was not my intention, but that's all right. Okay. So I got my switches. I need my resistors. I need my pull-down resistors. So the center of my 2 resistors here, right here, that spot, that's what's going to go to each of these switches. So actually, I'm going to move these up so I got some more room to play here. Okay, so this wire right here is going to go to one side of that switch. It's going to be our red, and then same thing, jump into that one, and jumping to that one. So I've got this wire going to this side of this switch, this side, and this side. That's what I just did. Okay. Now, they need to run to a 100K ohm resistor. And so I'm going to go center. Okay. So I'm going to go my center pin. I'm going to make that 100K ohm. And I'm just going to copy, paste, and paste. And then I need to make sure each of those gets to ground. Ground, black, ground, black, ground, black. All right, so I got most of this. I'm going to have to bring in my H bridge. So that's the L293D. I'll just search for that. L293D. There it is. So we're going to take that, put it right about there. Give ourselves just a little bit of space. Okay. Before I forget, I'm going to wire my 5-volt power supply. Over to positive here. And negative here. And then I'm also going to run it to the other bus. I'm going to go ahead and do it on the far side here. Whoa. Take my ground to my ground. And my 5 volts to my 5 volts. There we go. So that way I've got 5 volts and ground up here too. Okay, cool. So my H bridge wiring, that's here. Okay, that's what I'm looking for. Zoom in a touch. So my voltage for the chip is 5 volts. So that comes right here. And my enable, to turn that on, that is also 5 volts. So I'll just run that down here. So that's pin 1 and pin 16. We ran those both to 5 volts. Okay. 1A, this one right here, that would be my the ground for my external power supply, which is this weird diagonal one here. So bring that out. Okay. Then, let's see, 3 and 6 go to my motor. So I'll go ahead and take 3 and 6 over there. Here's 3. And it doesn't really matter in this case. Whoa, what have I done? It doesn't really matter in this case which terminal is which. It would just spin one way or the other. So in this case, it doesn't really matter. So that was 3, and then 4, 5, 6. Okay. So looking pretty good. 4 and 5 need to be grounded. Well, one of them needs to be grounded, so I'm just going to take 5 and run it to ground. Black. Okay. And then we got 7 and 8 here. So 7 is from the circuit, right? So I haven't done that yet, so we'll leave that guy out. But then 8 is our external power supply. So we'll take that right down here. That'd be our external power supply. Now the cool thing about that, because the way the L293 works, right now this is set at 6 volts, but I think I can go up to like 20 volts, 24 volts or whatever, and it still will control it properly. which is nice. So I can have motors that have much greater voltage or current requirements using this H-bridge L293D. Okay, so I think, if I'm not mistaken, we've done everything in here. Everything except this right here, right? We haven't done this circuit. So for that, I'm actually going to pop over to Multisim Live to design it first. Actually, you know what? I'll just do it on Multisim proper because I've got that installed in this computer. That'll be a little faster. So what we need is we basically need an event detector circuit and a simple logic circuit. So my logic is if A and B are tripped, two adjacent switches, or if B and C are tripped. So I'm just going to go ahead and place 74LS08. So this would be like A and B. This would be B and C. And then I need a 74LS32. Oops. 32. That's my OR gate. We'll pop that down right there. So that would be my logic, right? If A and B are hit, if they're right next to each other, we have a paper jam. And so then I have a signal coming out. If B and C are hit, then I've got a paper jam. So that's all the logic needs to be. Now we have to build the event detector. So for that, we need a D flip-flop, 74LS74. We'll drop that down here. And for that, we've got VCC. We're going to attach a VCC to both our preset and D. Our clock is going to get triggered here. Okay. And then this would go to my motor out here. And the reason that Q naught goes to my motor is because I want my motor to be running most of the time. So when this is 0, this is 1. I want my motor running. And then when this thing triggers, I want my motor to shut off. So I'm going to probably connect it to Q naught, but we'll see how that works. So when this ticks, when this detects a copier paper jam, this clock will raise to a 1. It'll check D. D is going to be 1. It has to be because it's tied to 5 volts. And so Q will be 1. Then this thing could be ticking, tick, 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 all over the place. It doesn't matter because D is always 1. So Q will be locked into 1. Your motor is going to be locked off no matter what happens with these switches. So we're going to have to put in some sort of way to reset the circuit down here. Okay. And so for that, we're going to put in what would be a button, right? So another push button. So I'm going to go ahead and I'll go ahead and put in this one. So there's like a push button. And this is the same type of one you'd see in TinkerCAD. Now, when it's not being pressed, it's a 0. So I'll probably want to do like an inverter, right? I think there's inverters in TinkerCAD. I better check. 74LS. Oops. 74LS04. Uh-oh. Maybe not. Oh, there we go. 74HC04. Okay, fine. So we have inverters. We're good. So we'll go ahead. They've got them in there. So we'll try one of those. Okay. So that's our general setup, right? That's the circuit that we want to create. And I mentioned in the earlier video that this is not a wonderful circuit. This has a kind of a serious flaw wherein if you have a paper jam and you don't clear it, you're just like, meh, I'm just going to hit the reset button. The machine will start back up. Your motor will start spinning. That's really dangerous. Not only for your machine, right? But, you know, if your hands are in there and somebody's like, oh, I'm just going to press this button, all of a sudden this machine kicks back on, even if the jam isn't cleared. That's a big problem. So what we probably should do is modify this. But I'm going to do this one first, make it work, and then we'll talk about modifying it. So the reason I did multisim is because I wanted these pins right here, these footprint pins. So I'm going to come back over to TinkerCAD and I'm going to throw in these chips that I need. So I want to put my inverter over here. I'm also going to need 74LS08. Excuse me, HC08, right? That's what they've gotten here. HC08. So I'm going to bring one of those in. And 74HC32. So I got my OR gate, my AND gate, and then finally I'm going to need, what row? I'm running out of room. I have to scoot things over a bit here. My D flip-flop. My 7474. Okay, cool. So let's rearrange things a touch here. Let's get the AND gate real close because we're going to need that first, and then the OR gate, and then the flip-flop. Cool. All right, so before I do anything, I better power and ground everything, right? Otherwise I'll forget. So we're going to take power on pin 14 on each chip. So you may want to fast forward this section because it's going to take me a minute to do it. Let's see, and then the inverter. Okay, and then I also need to ground all of these chips. So I just ran those all to ground up there. Why didn't anybody tell me? All right, so that's ground. This needs to move to 5 volts. This needs to move to 5 volts. 5 volts. Okay. Back to it. Ground. Ground. And ground. Okay, so all the chips are powered and grounded. Now we can start to use them. So I know that switch A, which let's go ahead and call this switch A, needs to go to pin 1 on my AND gate. So I'm going to take right here above the resistor, take that, run it over. I'm going to zoom it a little bit because I don't want to actually get it in any of these lanes. I want it kind of in between. There we go. I'm going to go ahead and make it like a yellow. All right. So that's that. That first switch, A, goes to there. Okay, now this switch, B, I'll go up here. This is going to go to spot 2. On this gate. We'll go ahead and make that green. Okay, so that's these two. Then my output, pin 3, goes to pin 1 on the next, on the OR gate, right? So that this pin right here is going to go right there. And we'll go purple. It's pretty. Okay, now I need to wire the other 2 switches to here. And this would be 4 and 5, but this is the same switch, right? This is still B. I have A, B, B, C. So these are the same. So I'm actually just going to piggyback this over to here. I'm going to keep the color the same so we know that's B. And then I'm going to wire up C. Switch C is here. And let's see, turquoise, pretty. Okay, so now I've got my switches wired up. I've got this one output to the OR gate. I still need to output this one to the OR gate. So the output is this pin right here. So we're going to take this and run it there. Purple. Okay, cool. So then, now we're over on this section. So that output runs to pin 3 on my flip-flops, right? So here's my flip-flop. Here's my output of my OR gate. So that's going to run over to pin 3 on my flip-flop. Pink. Pin 2 needs to run to 5 volts. Pin 4 needs to run to 5 volts. So we're going to go ahead and run those. Bottom one's 5 volts, right? I better check to be sure. Yep, okay. Pin 4 also needs to run to, oh, you know what's weird though? In Multisim, I believe this 74HC74, I believe, we better check. I think that might be active low, 74HC74. No, we're okay. So we'll go ahead and we'll run it to 5 volts because we're not using it. Cool. All right. So then pin 5 and 6, one of them, and I'm going to guess it's 6, is going to go to our H bridge. The one we didn't hook up on an H bridge, pin 7 over here. So that's going to go over to pin 6 on the flip-flop. Blue. Okay. We don't need the other flip-flop, so we can leave this other side totally disconnected. No issues there. The only thing we haven't wired here is our button. Okay, so that's pin 1, and it needs to go to an inverter. So we're going to take this over here to the output of an inverter. I'm running out of colors here. Orange, I guess. And then the input of this needs to be fed by a button. I don't know if I have room for a button here. I may have to bring in another type of button. Ooh, all right. We got just a little bit of room. We'll make it work. Okay, so that button, okay, that button we still need to do like a pull-up because it's not going to like being disconnected. So much like we did here with these pull-ups or pull-downs rather, that's what we're going to do there. We're going to use a 100K ohm resistor that goes to ground, and then we're going to run that to our switch. So we're going to take a 100K ohm resistor, run it to ground, and that goes to our switch. That same spot feeds our inverter. Okay. And then the other end of that goes to our power supply, our 5 volts. The reason we do this is so when it's not connected, when we're not pressing the button, it's going to ground. So it's like, yep, you're grounded, everything's good. But when I press it, it will give the 5 volts. So I think we might be there, guys. I think we might actually have everything done with one minor issue. They wanted an LED to tell us that there's a jam. So on the output, on Q of this flip-flop, they want an LED. So that's the last thing we need to do, I think. And the output would be the one we didn't do, right? Which would be this one here, pin 5. So we'll take pin 5 and a resistor and an LED. Where's my LEDs? LED. Again, I don't have a good spot for it. I'll put it there, I guess. So we'll run our anode. Over to right here. Gray. Okay. And then we'll take, I'm going to put a resistor on it just so it doesn't burn it out. So we use a 220 ohm resistor no, don't put it there. 220 ohm resistor is going to have to go here. Ohms, and that goes to ground. Okay, so that's a lot of things wired. Took us about 20 minutes or so to get that all wired, but we got it hooked up now. So right now, let's all the switches are being pressed right now. So when we start the simulation, in theory, it should go ahead and stop the motor, I would think. Let's see. 0 RPM. Okay, our power supplies are on, and the light is on, which indicates that there is a jam. So let's go ahead and turn these switches off. Okay, there still indicates a jam. Let me go ahead and reset it. The light turned off. Okay, but the motor does not spin. So let's see what the story with that is. It's going to have to be something with our H-bridge, right? If our H-bridge didn't work, that would give us our problem. So that looks right. We got 5 volts going everywhere. I wonder if it's our voltage divider. I wonder if it doesn't like the smaller voltage going in. But no, that would indicate the jam. Let's see if we can still indicate the jam. Yep. So our flip-flop is getting everything. So it's not the voltage divider. It's got to be something with our L293D. So let's check that out. So we have our enable is connected to 5 volts. So we are enabling it. We have our power input. You know what we need to do? We didn't do a common ground between the L293. We need to probably do maybe another common ground here. So let's actually ground pin 2 as well. Let's go ahead and take that to ground. Let's see if that does anything for us. Off, 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 clear. And there's the motor spinning. Okay, so yeah, so because we have 2 power supplies, we need to make sure that they share a common ground. So both of their grounds end up being connected. So our motor is spinning. Let's go ahead and try and get a jam here. Let's see, if I do the 2 outside ones, it shouldn't be a jam. It is not. Good. Okay, so first and second, boom, there it jammed. The motor shuts off. Good. Now here's the problem. Well, let me test the other one, the other combination first before I talk about problems. Reset. All right, so now B and C. Yep, that works too. Okay, anyway, so here's the problem I'm talking about. The paper's jammed, it's in there. You're going to get in there and pull it out. So you open the case and you get your hands in there and somebody presses the reset button. The motor starts spinning. Even though there's clearly still a jam, right? So we have a problem with that. So we're going to have to clear our jam. And then it's still running, right? So how would we solve that? Well, two things. So we're going to go back to multisim right here. So really what I want is I should only be able to clear it if I press the button and this is a 0, right? The jam is already cleared. So that really would do it for me. So if I press this and this is a 1. So what I'm going to do is I'm going to take another AND gate, and lucky we already have them in there, right? So we don't have to add a chip or anything. So I'm going to add another one right here. And I'm going to take my button and my OR gate, just like that. And that's going to feed in to here. Now, technically, I could make this a NAND gate, which they have in TinkerCAD, but then I'd have to bring in a whole other chip, right? I don't want to do that. So that's pretty cool. Now, the LED, the other thing is the LED right now is connected here, which tells me that the motor is off, is really what it tells me. It doesn't tell me there's a jam. It tells me the motor's off. So the other thing I would fix, if I were you, is I would take the LED, instead of being over here, I'd put it here, right on pin 3. So there's a lot going on pin 3. Pin 3 of this OR gate is going to go to pin 9 on the AND gate and clock on the flip-flop and the LED. So let's see what that looks like. We're going to go back over here. Pin 3, this is the hot spot right here. Okay. It's going to that flip-flop, that's already there, but it's also going to go to my LED. So instead of this gray wire going to my flip-flop, ooh, yikes, we'll just go ahead and delete it. And we'll run it also to pin 3. There. Okay. And also to the one of the inputs on this AND gate. Pin 9 is what they wanted. So here's pin 9 right here. So we'll take that. Get a little crazy here. Going to pin 9. We'll keep that purple. Okay. So that goes there. The other pin 10, which is this one here, that's our switch. So it previously went right here. So we're going to get rid of that wire. And we're going to take it up over and right there. Make that orange. And then the output, which would be this pin 10 here, excuse me, pin 8 here, that's going to go where this orange wire was. In fact, let's not do that. We'll go here. It was in pin 1 of this inverter here, right? So we'll take this over, down, over, make that orange. Okay, so here we go, starting the simulation. It thinks there's a jam. The motor's off. Now you'll notice as soon as I turn this off, the light goes off. There's no longer a jam. However, the motor hasn't started spinning yet. And that's really what we want, right? We want it to indicate that the jam is cleared, right? That's good. Oh, look, there's a jam. Oh, I've cleared the jam. But the motor doesn't kick back on until I hit this switch. Uh-oh. My reset switch is not doing what it should be doing. So let's see. we have when you press the switch, it should be sending a signal to input 3B. I wonder if that's not connected. It sure looks connected. Let's double check. Okay, that's in there. You're not randomly connecting anything else? No. I wonder if I just wasn't in there. Let's see. Jam. Jam is done. Reset. Still isn't working. Let's see. I wish this thing had, maybe it does. Let's see. We need like a logic probe. That would be awesome. But no such thing, no such luck. Okay, so we must be, when we are triggering it, or must be not sending it the right reset. So let's, when it's 0, we got a 0 going to here. 1. No, oh, I see. Here's what we've done. What we're saying here in this one is if there's a jam and you press the button, then reset. We actually want if there's no jam. So you know what we need is we need an inverter right here. That's our problem. So yeah, we need to do an inverter between that and that. That's what we need. Okay, not a big deal. We can do that. Just make the wires just a teensy bit messier, but that's all right. So pin 3 on here, it went up to the AND gate right here. That's the signal we got to intercept. So we're going to delete that. We're going to take pin 3 over to the inverter. We're going to make it purple. And we're going to take pin 4 out of the inverter and back up to this input. Oops. Oh no. Oh no. Don't do that. All right. I feel pretty confident about that. Prove me wrong, TinkerCAD. All right. So the jam is cleared. The motor is not spinning. It shouldn't be. Then we hit our reset switch. And our motor's spinning. Great. All right. So if I toggle these, no jam, motor still spinning. Jam, motor stops spinning. Jam is cleared, but I haven't reset it. Motor does not start again. Now here's the $1 million question. I'm really going to push my luck here. If I hit the reset button and the jam is still there, let's see what happens. Reset, 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 reset. Excellent. So the motor does not kick back on because you still have a jam there. But once you clear it, you come back and hit your reset, the motor can spin. So there it is. 39 minutes later, we've got this thing wired up, set up, and hopefully you can do it faster than I can now, now that you got it worked out. I'll have this shared in the description so you can mess with it. All right.